I'm just going to briefly introduce our panelists here, and I would welcome everybody to have I think everybody is visible. Thank you so much. It's nice to see you all. I'm going to give a really short introduction to just who they are, talk a little bit more about this geospatial literacy, and then each of our panelists are going to spend a few minutes talking about their own personal connection to that and introducing themselves a little bit more. And then I've got some questions that we will engage with the panel. So let me introduce quickly Dr. Tanya Harrison, Director of Science Strategy at Planet Labs. We heard from her earlier. She holds a PhD in geology with a specialization in planetary science and exploration from the University of Western Ontario. Some fabulous insights into what are those skills and that trajectory to get you into the positions of using geospatial technology and data in her field. Morgan Crowley of McGill University. She's a PhD candidate and remote sensing specialist in the Department of Natural Resource Sciences there. And her research focuses on mapping and analyzing wildfire progressions in Canada. And while she's broadly interested in satellite remote sensing, wildland fires, and geospatial ecology, using Google Earth Engine as well, she's also engaged in multiple external collaborations examining social ecological systems. We also have Sarah Banks, and welcome, Sarah. Sarah is a physical scientist and synthetic aperture radar specialist at Environment and Climate Change Canada in the Landscape Science and Technology Division. I believe you're a PhD student at Carleton or have been accepted to that as well. Yeah, congratulations. For over 10 years, Sarah has applied traditional and developed new remote sensing techniques for mapping, monitoring, and characterizing changes to Canadian ecosystems. And much of her research has focused on wetlands, something absolutely critically important to be studied. Sarah is both a co-founder and contributor to Sisters of SAR on Twitter, which focuses on showcasing and promoting the accomplishments of women in STEM, especially in remote sensing and radar remote sensing. And Parshati Patel, astrophysicist and science communicator at Institute for Earth and Space Exploration at Western University, and an adjunct research professor, the Faculty of Education, Western University. Her interests and expertise includes stellar astronomy, science communication, and STEM education. She advocates for women of color and women in STEM and co-founded Women of Color in STEAM, with two M's, in Canada. And so, in a minute, I'm going to let them just speak a little bit more to their own personal experience and ties to this topic. But what I would like to do right now, let's see how, I've been watching everybody else do this. Let's see how proficient I can be in this. I think we're there. Yes, here's our panel. And we're talking about geospatial literacy. We've been talking about it for 2 hours and seen some great examples. But if we break down what that is, what is that definition of geospatial literacy? Well, we want to think of it as knowledge. We want to think of it as skills and dispositions. It is not enough to have those skills and knowledge of how to write geographically or read geospatial information if you don't know when to apply that or when to use that knowledge. So that's a really important piece of looking at literacy. And we can apply much of what we know to writing, literacy, writing and reading, to geospatial representations. There has been obviously such a change in going from cartographically authored maps, things that look like pictures and graphics, to an image that has to be interpreted. So we show Google Earth to students. My own research, I've been doing research in geospatial education and geospatial literacy for 15, probably 20 years now. And the change in what we've seen in terms of representations of Earth that students have to use and workers have to use in terms of understanding the Earth better. We've gone from this cartoonish look of the Earth to these satellite images that show us such great detail, and we can choose what we want to see of that. How does that affect a student's ability, right? How does somebody learn to interpret those things? Our pedagogies have not changed very much in K-12, and I hope that's a discussion we get into, is that we still talk about maps as this cartoon, this drawing, completely authored representation, and yet now we've moved into the area of rocket science and pocket science, where students can be the authors and of the images that they see, and they have agency in how and when they look, right, at different parts of the image. So there's a lot of questions there. Some of the work I do is around eye tracking, so that we can see how students are actually reading and interpreting different data sets, geospatial data sets. And there's the whole issue of cognitive science. Students do a progression of learning spatially and thinking spatially. One of those key aspects is going from an oblique perspective, what you see as you walk on the street, to looking straight down. And many of our satellite images, drone images, are looking at that nadir perspective straight down. And I just offer the image on the left as an example. This is very typical of someone in about grade 3, maybe about age 8. They're not quite there. The roads they can picture as nadir, looking straight down, but the houses have an oblique perspective. And so a lot of what we assume students actually take up from some of these geospatial representations, and adults too, I might add, is actually lost to them. So very important to think about what are those learning progressions and the learning requirements of our students, and also adults who might be looking at some of this type of imagery without having the background education, skills, knowledge to do so. And finally, I'll bring up the point, and this was really the issue around that question to Trevor, is we have, how do we do this with different communities? Communities around the world are using these representations in the data. When I started, it was very much a privileged small group. Many of the people my age, we all know each other because it was such a small community. You didn't have easy access to data. Now it can be everywhere. It can be used by communities. They can be applying their own knowledge and language, knowledge of the land, to geospatial data sets. And this is what's been really key in the Arctic, is that I can't interpret these images as well as my Inuit colleagues there. So yeah, a lot of questions, a lot of fantastic issues that we need to explore further, and we'll begin by this panel. So I will invite Tanya. Would you mind just giving an introduction to yourself for our audience here? And I'll get out of screen sharing.
Sure. So sorry if anybody was tuned in earlier and already got to basically hear my entire life story coming into the geospatial realm. For those that didn't, I'm Dr. Tanya Harrison, and I'm currently the Director of Science Strategy at Planet, which, if you're not familiar with them, they are a commercial Earth observing company that operates about 200 satellites currently in orbit, imaging the entire landmass of the Earth every single day at 3.7-ish meter resolution to look for change. This is obviously a huge treasure trove of geospatial data. We downlink about 25 terabytes of data every single day. So that's more than any number of graduate students could ever go through in their entire PhD careers. So geospatial literacy is really important for being able to go through huge data sets like this, because we need to be able to understand what is sitting in that giant wealth of data. It's not worth it just to collect it and have it sitting there on a server. There's information in there that we can be extracting. And so a lot of my role at Planet is to work with the research community across a broad array of different fields to try and figure out how they can best harness this type of data to do their research. And it's been a really interesting experience because this is an entirely new data set. We're not used to having this dynamic, high resolution, both in terms of spatial and temporal aspects, data in this constant feed. People are used to things like Landsat, which gives you this great historical record back, gosh, 40 years now. That sounds like so long. And then we have the Sentinel program from the European Space Agency extending for the last few years, giving us higher cadence and a bit higher higher spatial resolution than Landsat. And then you have lots of other satellites that are operating, outside of the optical, giving us thermal information and synthetic aperture radar. And we're seeing like fusion of these data sets together to give us even more insights than we would have with any one data set on its own. But specifically looking at this near daily high spatial resolution data, researchers are really trying to figure out, how do I use this and how do I consume that much data and actually pull information out of it? And so it's almost like a new type of geospatial literacy in that, what do we do with this new data set? How do we integrate it with our existing workflows? And what are the possibilities? Like, what could we be doing that we haven't been able to do because we didn't have data like this before? And to me, that's the most exciting part, like getting to ideate with folks and see what they're working on and try to think about how you can take this new data set and plug it into the mosaic of all the other data sets that are out there to try and get the maximum benefit from all of it.
Thank you so much. Yeah, really important questions. And I know we're going to be discussing some of that. How do we ask those good questions and use this data appropriately? That's an important piece of literacy. Sarah, would you like to go ahead?
I have a couple of slides, so I'll just share my screen. So hi everyone, I hope you can hear me. I'm really happy to be here and thankful to be invited to participate in the panel. My name is Sarah Banks, and as was mentioned before, I'm a physical scientist within the Landscape Science and Technology Division of Environment and Climate Change Canada. And my job is to work as a physical scientist within a geomatics lab. So our focus is on mapping and monitoring both ecosystems more generally and important species habitat more specifically. So to do this, we use a lot of geospatial data. We collect data in the field. We collect data from drones and from satellite imagery, use different sources of GIS, which we then analyze for classification, for modeling. We also evaluate the accuracy of those products. And then we also visualize and disseminate this information through maps and publications. The research that I do really focuses on wetland mapping and monitoring, and also looking at whether we can map invasive species from space. And the example here I'm providing is Phragmites. So if you're not aware, this is a really aggressive invasive species that's found throughout the entire Great Lakes and is very hard to get rid of. So what's the importance of geospatial literacy for what we do? Well, the way in which we study the environment and environmental phenomenon at Environment Canada is rooted in spatial thinking. We're constantly trying to identify differences in species habitat quality and quantity, both through space and through time. So everything we do has a spatial component. For example, we're trying to map wetlands across all of Canada. And so having geospatial literacy within our lab is very important because there's a lot of issues that come with that. Things like the impact of spatial autocorrelation and trying to come up with spatial models and methods that predict changes through space and time. I'm also part of an initiative that was started between myself and some other colleagues that I'll talk about in a second. It's called the Sisters of SAR, which is our Twitter handle. And we really focus on advocating for the status and recognition of women in remote sensing and other STEM fields. And we're all specifically really passionate about synthetic aperture radar, which is a method of remote sensing where we transmit and receive microwaves. So it's a little bit different from optical data if you're used to hearing about that, but it provides a different but complementary look at the Earth's surface. And what's really interesting about synthetic aperture radar is that It's generally not affected by atmospheric conditions, so you can see through haze and clouds. So my colleagues and I, Dr. Gopika Suresh, Laura Dingle-Robertson, and Orla Sheraton, were all co-contributors on the Sisters of SAR. And I just wanted to talk about what we do. We have a tweeting schedule, and I'll just go through each day what we usually talk about. On Monday, we tweet SAR facts. So just providing some information about what radar is and what are the new satellites coming out, because there's so much going on. There's constant change happening within the synthetic aperture radar community. So it's a nice way to just keep people abreast of all that information. Training Tuesday, we identify training resources for people about synthetic aperture radar and other remote sensing methods and techniques. On Diversity Day, we tweet about different Twitter accounts that are identifying and promoting equality and representation within STEM fields. And on Thursdays, we tweet really great images about synthetic aperture radar, just to show how amazing and beautiful it can be to those who've never looked at it or have this misconception that it's just really noisy data and don't really want to use it. And then on Fridays, we like to highlight a woman working in remote sensing, especially in radar remote sensing, just to advocate for their status and to recognize the great contributions people are making in remote sensing. And that's all about me.
Great, thank you so much. And yeah, I've been working in SAR since 1993. It's not sometimes we think of it as new, but Canada has been a leader in SAR since before RadarSat, right? With the Terra information technologies using radar remote sensing to map ice in the northern areas. So yeah, fantastic to see that legacy just grow and grow. Wonderful work.
Absolutely, absolutely.
Parshati, now, we were going to connect beforehand if we could, because it's important in terms of literacy to be able to not only to read, but to pronounce people's names correctly. And I wanted to be very specific about yours, and we didn't have a chance to meet, so you can correct me on on any pronunciation of your name.
Yeah, Parshati, it was correct. Thank you. So thank you for having me on this panel. My background is very different from a lot of people here on the panel. So my background is actually in astronomy. I'm an astronomer by training. My PhD is in astronomy and planetary science. So that's where that planetary aspect comes in. But I want to kind of, take you guys, I guess, in the couple minutes I have on a journey. So I came to Canada in 2006 to study astronomy. And my first foray into GIS was when I took an elective course in GIS, and I really liked it. And I took a second course because we were supposed to get 2 elective credits. And so I took a second course, and then I really liked it. And I realized that GIS could be used in geology. So I ended up taking a 4th-year geology course with having taken no other geology courses before, but having that physics background, I was able to actually use geology and GIS together to kind of understand, and then a mixed combination of physics students and geology students. It really helped me to kind of, bridge that gap of not knowing much of geology while coming into 4th-year course. And I really liked that aspect of, just understanding Earth from a different perspective. And that's something that I'd never thought about before. And when I moved to Western to do my master's, I realized that there was a planetary science collaborative specialization, which Oz is the director of. And I was able to take that particular specialization and kind of broaden my horizon from just studying astronomy to incorporating things into planetary science. And again, that knowledge from GIS kind of came in handy when I was taking all of these courses, trying to understand, mapping Mars and other things, and trying to gauge what other planetary scientists do. And when I moved on to my PhD, again, I was doing astronomy, and collaborative specialization allowed me to kind of, bring this other needs of things that I never had during my master's or during my bachelor's. What's also really unique in a way that during my PhD, I started volunteering and then eventually kind of working for the Institute for Earth and Space Exploration in the outreach and education side. And this is really where I got to use the knowledge that very little knowledge that I acquired in my bachelor's and what I was learning from my fellow students in the program and their research to education. And so currently I work as an education outreach and communication specialist at the Institute for Earth and Space Exploration. But I'm on leave right now. I'm on a secondment to another agency where I'm working also in the field of education. And I've really kind of started seeing that space involves not only, it involves Earth. A lot of people forget about that. They think about planets and stars, and they don't think Earth is a planet. It's part of a solar system. There are so many things that, we look back at Earth, we look at the things here, and we kind of apply to other places. And one of the, I think, one example of where we have kind of, looked at Earth to kind of talk about other places in the solar system is this really neat activity where we started, I think Tanya would probably know, she was part of the initial group that came up with the activity where they start actually mapping Mars, but they start by looking at Earth, and then the things that we can see here on Earth, and very simply done by using Google Earth Pro. They're looking at Earth, over time. They're looking at data over time on how things have changed. Kind of, these are students in middle school or sometimes even high school that are looking at this data. They're interpreting what's on Earth and how they can actually, understand what the processes are going on here on Earth, and then take that information and apply to other places, whether it's Mercury, Mars, or other places in the solar system. So my particular journey is very different from a lot of everyone here, but I hope to bring that unique perspective of being able to work in education, develop these activities for students, work with them to kind of understand how they interpret these things and what they have in terms of their idea of why are we using satellites? Why are we looking back on Earth? What does this have to do with my daily life? One of the most important questions many people ask, why does it matter? So kind of taking all of those links. And so, yeah, that's kind of my story into geoliteracy in this context. So thank you for having me.
That's fabulous. Thank you so much. And Morgan, can you introduce yourself to us, please?
Yeah, thank you so much. So as was said, I'm Morgan Crowley. I'm a PhD candidate at McGill University, and I'm working primarily with the Canadian Forest Service to map and monitor wildfires in Canada. And I don't think they knew this when they asked me to be on this panel, but I actually grew up with, my mom was a geography teacher for 40 plus years, and my grandfather was a US Air Force pilot. So I grew up a lot with maps and with aerial photographs at a really young age. And I never quite realized how much it influenced me until I got to undergrad and started taking courses, and GIS and remote sensing really jumped out at me the most. From that, I moved from New Hampshire, where I grew up, to do my undergrad training at McGill, and then returned to the States for a master's to do some qualitative GIS research with forest landowners in the US West, and then returned to McGill for my remote sensing heavy PhD. And I guess I'm also a member of the organizational board of Ladies of Landsat, and I'm just going to share my screen for a little bit of an overview of that. I just present, sorry. Okay. Yeah, okay. So Ladies of Landsat is a Twitter-based organization, and we're aiming to make the field of remote sensing more equitable and inclusive for underrepresented scientists. And the reason I got involved with Ladies of Landsat is I'm in a computational landscape ecology lab. So it was primarily male-dominated. I was the only female student for many years in my lab when I started. I felt pretty isolated and alone coming from kind of this mixed social sciences background, and I connected with some women at a Forest Sat conference who had started this organization, Ladies of Landsat. Sorry, so you can see here a LiDAR image of one of our meetups at a conference. And so we're kind of doing all remote sensing really. And so we've had to increase our geospatial literacy, to share this knowledge that we have. And it, we've worked for a variety of efforts basically to tie, to spread this, to connect people in the field, and also to increase geospatial literacy. So we've had meetups in person that connect students, professionals, and academics together. We've met up at the User Summit for Earth Engine, which is from Google Earth, at ForestSat, which is a professional conference, at Geo for Good, which is a user summit for Google Earth, the Landsat Science Team meeting, which is a professional meeting. And more recently, we've been connecting folks virtually with Sisters of SARS and some other organizations through a virtual networking meetup, basically to connect folks that previously would meet at conferences but haven't been able to. But as doing this, we've actually been able to connect with folks who pre-COVID times weren't able to come to conferences because of the cost as well. We also have a weekly Manuscript Monday series to highlight women-led remote sensing research. And the aim of this is to increase visibility and citations of this research. So we take basically long, complex scientific articles and communicate their findings in digestible tweets. So you can see some right here. We've talked about machine learning, about looking at droughts and food insecurity using MODIS, and then also LIDAR and using field data for mapping mangrove biomass estimates. And more recently, we've been working with the USGS Human Dimensions team to interview Landsat users and create these 3-minute videos of Landsat users, their interviews, and how they're using the data. And so first one that we did, we just released these last month, and we're continuing to actually collect more interviews right now. So first we did a backgrounds of ladies Landsat. And then we have 2 about interviews with Landsat users, Jill Dinas, who is based at Stanford, and Africa Flores Anderson, who's based at Servier in the United States with NASA, and basically telling their stories, how they got to use Landsat, how they basically the entire career journey, what kind of brought them to this type of science, and what they're doing now. And so these have been actually picked up by the USGS YES group, which is the Youth and Education Science group, basically to share in a digestible way potential opportunities in the field of remote sensing. So these are just kind of 3 of our many efforts that I wanted to share as they relate to building capacity for geospatial literacy. You'll find that a lot of our original target was really supporting the folks in the field, but now we've kind of been shifting to communicating to outside the field as well. So thank you. I'm happy to be here today.
Wonderful. Thank you so much. In that short amount of time, I actually turned off my video because I have now joined Geo for Good, Sisters of SAR, and Ladies, which I encourage all of you to do. Yeah, and for those who have just joined us, since I introduced myself about 2 hours ago, my name is Lynn Moorman. I'm a professor of Earth and Environmental Science at Mount Royal University in Calgary, Alberta. I teach geospatial analysis, but also physical geography, and I'm a governor of the Royal Canadian Geographical Society of Canada, who has really been putting on this session today. So thanks for all the support from that organization and GeoIgnite for being able to bring us all together today. Yeah, and so I just wanted to introduce my background as well. I was actually an astrophysics student, and I think, Tanya, I think you can relate to this as well as Parshadi. And there's a lot of us in the remote sensing community who started as astronomers, astrophysicists, and then realized we could turn those sensors around, right? And not look at space, but look down on Earth and learn more about where we're from. And that certainly happened to me. Boy, had I been young enough to go to the University of Western Ontario in that program, I certainly would have. I was considering Arizona, but I never got there. And so I ended up doing a lot of physical geography, but a lot of field work. And I knew every part of Canada so well that I ended up getting a job with the Canada Centre for Remote Sensing, because we were using sensors like Landsat, AVHRR, to map Canada's landscape and land use types. And they needed somebody who could look at an image and know exactly where it is and what was on the ground. So luckily, that was me, and that's how I ended up getting back into that remote sensing side that I really wanted at a time when there wasn't a lot of opportunities available. And then I was hired by Intera, Information Technologies, to develop SAR training, synthetic aperture radar training. We took that around the world. Tropical areas needed to be mapped. Higher Arctic areas needed to be mapped, and radar was the key for that. And one thing that I realized was that every acquisition program we had, every time we were delivering data, education was a huge component. You couldn't just have the data without having the education piece. And from that, I ended up doing a PhD in education because I needed the education language. I needed that education theory and the ability to translate geospatial to teachers, to students, to learners. So that's where I've come from in this journey, and I think it connects with all of you in different ways, and a fabulous opportunity for us to get together and to answer some of these big questions. So many of you have mentioned already, what was the main aspect of geoliteracy that's important in your work? But if you want to add on to that, so what have been the influences in shaping your own development? So building your own geoliteracy so that you could do the job that you're doing now. Just put up your hand if anyone wants to start, and I'll pick from there. Yeah, go ahead, Parsha.
As someone who had probably the least training in this, I work with experts and kind of take, what they are doing, incorporating that in a lot of the activities that we develop for students. And I actually get to learn from them every time, they're doing, whether it's remote sensing of craters on Titan or whatever they're looking at. I have to kind of interpret. And so I'm learning with them. And so my learning has gone from that undergraduate course of like the very, very basic understanding of GIS and remote sensing to kind of somewhat understanding of like, I know what the technical terms they are using, and I know how to like translate that for students and put it in an age appropriate level. So, my learning, I think I would not have been where I am today if it wasn't for all those experiences and all those amazing activities that came before me, and kind of taking those and understanding how that was interpreted by students and educators and what they found useful out of those activities to be able to develop my understanding for, it's not just kind of for activities in general too. When you're talking about space, people have questions from all directions, whether it's about spending so much money on a particular thing to, why are we using this and how is this beneficial to us here on Earth? So kind of bringing that point back when we are looking at things outside, as you said, turning those cameras back on Earth and why it's useful to people here. So my trajectory has been varying every time, but I've been learning every time, I've had a chance to work with an expert.
Great, thank you. Anybody else to add to that particular question? We have lots of questions we can go through, so.
Sure. Yeah, I guess like in my research, it's been really interesting because when I'm talking to different folks in the fire community, I found that we're all talking about similar things, but using different words. And so part of a lot of my research has been kind of tying together what are the data needs of these different groups of the fire kind of cycle. What do people need in the field to manage their forest, but what also do firefighters need, and how does that differ in terms of the geospatial data that we provide them? And that varies differently from when I was in my master's talking to landowners and seeing what they needed and how fast of the data they needed. And so that's been kind of what I've seen from that side. But from an outside, speaking outside the research community, I spent a lot of time in my mom's classroom teaching kids, Google Earth, how to collect GIS points, and thinking about the data from their side and what really resonated with them. And it's interesting how we can kind of look at all the different users basically and communicate geoliteracy in a different way to them.
Yeah, tying to both that and what Parshti was saying, a big aspect of geoliteracy is being able to act as a translator, not just between like other communities that are using the data, but the end user as well, because the data itself is not actually all that useful to a large number of people. If you have like your farmer that's trying to get insights to figure out when to water his crops so that he'll get the biggest yield, you can't just say, here's a bunch of satellite imagery and have him figure it out. It's like handing somebody a bunch of ingredients to a recipe where you might not even know what the end result is supposed to be. You're just like, here's some ingredients, make something. And so we need to be able to process that data for people so that we can help actually get the insights out the other side to say, this is how this data can benefit you by telling you X, Y, Z, and then we can move forward from there. And that's the trickier part because there are so few of us relative to the number of people, those of us that use the data versus the people that could be using the insights from that data.
Yeah, great. And if I can elaborate on that, I mean, you were already talking about this, Tanya, in terms of we need to be able to ask the right questions and we need people to have this vocabulary and understand the concepts of this. Where does this start? You guys are doing a fantastic job of knowledge mobilization, getting this word out, public outreach. Does it need to go further? You heard me already. I think this is a fundamental literacy that needs to be included in K-12 education. What are your thoughts around how we bring the public to this level of geoliteracy that we need?
I think we really need to do a better job as academics presenting the information, like everyone knows, in a easily digestible format, and to take these complex ideas, these complex models, and as you guys were saying, present them in a way that people can really use that information and take something relevant away from that. And I think that's kind of the missing link. Is there's a lot of focus on publications in academia, but actually providing, useful and interpretable results to the end user, that's sort of a lesser focus. So I think we need to do more of that. And also to, like you said, bring more easily digestible kind of information to putting that into the curriculum so that people who are coming out of public schools have that geoliteracy that is sort of lacking or missing in some cases.
Parshni,
Sorry.
I was hoping you'd answer that. Yeah, go ahead.
Yeah, so I agree. K-12, it does have Earth and space systems, but there's only so many places it actually touches where we can actually utilize, a lot about what we're talking here. One of the things I've realized is educators, especially in K-8, they require a lot of support because most of the time they don't come with the background to be confident enough to be teaching any of these tools that people put out. And I think the most requests in the last 5 years that I've been working has been from K-8 teachers. And a lot of the times they say, hey, can you just teach this unit instead of like just teaching this one activity? And that's because they don't feel confident about doing that. So I think teacher training, making sure, whatever their doubts are, they're able to ask whoever is, out there doing that, putting out that particular activity, and why it matters and how it would actually, a lot of the times teachers really, really want to kind of adhere to, whatever they're supposed to be doing. But bringing, trying to change that it's in itself is a different game, trying to, get them to incorporate new things into the curriculum. When it is tied to the curriculum, it makes it much more easier. And then bringing that, how is this going to help your students? How is this going to help you? Kind of really helps to bring that message home. And I always believe starting young is the key.
Yeah, from my mom, when she was a 6th grade teacher, in her last 5 years of teaching, she took a local or like a GIS certificate course as part of her professional development. And she had been teaching geography for 35 years, so she really didn't need to overhaul things, but she was just so excited about it and could teach GIS to her students, could do, GPS collection when they'd go on field trips. And a geocaching was really what got them all into it a lot originally. But it was really neat, and it was really heavily supported by her school, and also the local university for providing that helped a lot. In her case, just an anecdotal experience.
Yeah, wonderful. And I want to ask Tanya a question in a minute relating to this, but I do also want to point out if we look geographically at the spatial distribution of the speakers we've had today and the speakers we have on this panel, you'll recognize there is a massive bias to the Central Eastern Canada. And I think I'm like the lone Western representative almost. So I will say, you know, K-12 curriculum is very different. We look to Ontario as the holy grail of geography learning. And so there's a lot missing on the Western side of things. So I think that's something also to consider is, you know, Canada's a big country. We have a lot of jurisdictions. We have a lot of different users with a lot of different experiences. And we always have to keep that in mind. So Tanya, with that in mind, I wanted to just follow up on that idea of, you know, you mentioned how do we get people to ask the right questions? How do they become knowledgeable enough to do that? You're talking about farmers. You can't just give them, you know, the map or the data. How else do we reach them? They're already through school. How do we meet the public in what we need in terms of geoliteracy?
I think a lot of it is just reaching out to those communities, kind of like the examples that we saw earlier in the session, talking to Indigenous communities in the Arctic to understand what they actually need and want from geospatial data. For example, go out and talk to the farmers, talk to, you know, Planet. We work with a lot of human rights organizations, for example. These aren't folks that have experience processing geospatial data, but by learning what kind of things that they are trying to track or look for or monitor, that way we can try to collaborate with them, think about like, okay, what are things that we could either directly observe in satellite imagery or things that we could infer from satellite imagery, or is there a way to combine satellite imagery maybe with data that you're getting on the ground to give you more information about a specific thing that you might be trying to see? So having those transdisciplinary conversations with different groups is really what's needed to be able to get to that next step of, rather than just tossing data at people, actually figuring out how to make that data useful for them.
Great. What are some of the biggest geoliteracy challenges you've seen in your work? And maybe even it might be colleagues. I can speak to students. There's a lot. Marking final exams, and I showed an image of rivers just looking down and the beautiful dendritic drainage pattern, and you should be able to tell a lot about the surface of the land and the way the river flows from there. 90% got it wrong. They said, don't rivers just flow north to south? So, you know, that's one example. I have it every day. I'm just curious about in your work, what kind of challenges do you see?
Well, so being in a computational landscape ecology lab, there's a lot of computer scientists that don't have a geography background. And so there's always a saying that I've said to them the entire time, because my master supervisor would say this to me: just because you can do something doesn't mean you should do something. And a lot of these kind of tenets of geography, they never learned. And so they don't know that, you know, you shouldn't use that projection for this calculation, or you need to do these transfers that you haven't thought about. And it happens all the time at research level. And, you know, it's awesome because so many people are interested in these cloud-based processing platforms, but then they also have to have the training to be able to use them as well. And sometimes there's a gap with that.
I definitely agree with that, Morgan. I've seen a lot of examples of, you know, sometimes it can be really tricky because people could you know, try and apply methods that have been developed for non-geospatial to geospatial data. And sometimes along the way, there's some missteps that, you know, you can generate results and those results may not be very accurate, or you could misinterpret the results based on the methods that you've used. And the one thing I see a lot of is people forgetting about the effects of spatial autocorrelation. So I definitely think that greater literacy around those tenets of geography that I definitely learned in school would be very helpful, I think.
Parshti or Tanya?
I think a lot of what I deal with personally tends to be like when you're at a commercial company, you have a lot of different backgrounds. You know, you've got salespeople, and you have like at least our company, we have engineers, and then we have image processing people, and some geospatial people, and some people that don't have geospatial backgrounds. And so communicating between all of those different groups to totally understand like what are the capabilities and limitations of the data sets can be really tricky, because there's, what people would want to do, and then like the realistic part of what they can do. And those conversations can always be tricky sometimes when you're having them between like technical and non-technical audiences. So just understanding, that even kind of goes as far as like trying to explain to somebody, for example, the limitations of resolution of images. This is where you start to get into conspiracy level folks who think they found alien bases on the moon and Mars, and it's really just because they've zoomed in so far to the images, you're beyond the resolution limit and you're just looking at JPEG artifacts or something like that. So getting people to understand like what you actually can and can't do with the data at a very basic level can be tricky. We're kind of spoiled because we work with this data all the time. And I think, Lynn, your example was really good. Like, to us, something like that with a river seems so obvious. Or I remember a few years ago doing the planetary science summer school at Western, where Oz was teaching. And most of the students in the class were planetary scientists, but my like lab partner, I guess you could say, was an engineer. And we'd been tasked with taking a screenshot from Google Maps and drawing a geologic map over the area before we went there in the field. And I'm sitting there clicking away in Photoshop, and my partner just looks at me and he's like, what are you clicking on? And I was like, I'm drawing the boundaries. He's like, I can't see any, this just looks like rocks to me. But as a geologist, I was like, oh no, there's these dark rocks, and then there's slightly darker rocks, and there's the lighter colored rocks and some chunky ones over here. But to an engineer, he'd never thought like anything looked any different. Rocks were rocks. And so realizing that not everybody sees the same things, it just in looking at a picture, is a really powerful realization, I guess. It also makes you feel better as a geologist, because we always get kind of ragged on by other sciences as being very qualitative and hand wavy, but seeing a brilliant engineer not be able to tell the difference between light rocks and dark rocks made me feel a little bit better. It's like, oh, okay, my PhD is worth something after all.
Thank you. So yeah, we've had some really important information about, it being a black box, right? And how dangerous that can actually be. And data, how well can you actually understand it? Parshadi, I'm going to give you a last word on this one here.
Yeah, I just wanted to kind of connect back to what Tanya was saying. It brought me back to this activity that we were doing with kids, just to give you guys an example that it's kind of similar at, at K-12 level too. Kids use phone all the time to take selfies and take pictures. It's a very common thing people do. But something that they don't realize is the importance of having a low resolution image and a high resolution image, and things that you can decipher, using both. There are so many, things that you can learn from a low resolution image that you may not be able to learn from a resolution image. And that sparks that go on in kids' eyes when they look at it, like, oh yeah, like I didn't see that in here, but I saw it in here. And it's like a simple thing that, they don't realize until like you're showing them two sets of different pictures. So, kind of, and teachers too, it's not just students, like they, when you interact with them and kind of show them these examples is when they actually realize the things that they have never thought about before. And I particularly like using images, because a lot of the kids could be visual in many cases, and some may not be, but the fact that, you put them in pairs, they're actually able to interpret these things. So I think the gap kind of comes from that, just, that simple two images could be telling you very different things, and something that you don't realize. It's not an auto response to things that a lot of people are used to, because you take pictures, all the time. That's not something that's an auto response. But again, kind of, going back to what I was saying before, that support to teachers could actually trigger that auto response when they are doing these activities, to then incorporate that into students when they're looking at data sets.
Wonderful. And I think, to kind of close out this conversation and bring the kind of synthesize what you've all just been mentioning, Eisner speaks of representation and literacy, in that, what forms of representation are emphasized, and in what forms are learners or students or the population expected to become literate. One thing that we know about looking at spatial representations is that our mental maps of the world are reified. They are solidified in the representations we become familiar with, hence the Mercator map in classrooms. And everything you've spoken about, Tanya, looking at the different tones, right, to represent different types of rock, just understanding that different data, the more that we can expose students and the population to different types of representation, the stronger those mental constructs of the world will be. And don't we all want that, right? A better understanding of the world. So I am going to kind of leave with that. Our time is done, but boy, do I ever want to do this with you again. Paul has mentioned we can create an advocacy and resource group. I think this is a fabulous group to do that. I think we need one that has very Canadian perspectives as well. I think it's absolutely critical. So I'm hoping this is just the start. Just like when you map something out, that's not the end point, right? That's the beginning of the questions of what's on the map. Let's go from here. Let's use this as a starting point today. So I want to thank you all so much on the panel for contributing. I know there's so much more we want to talk about. I want to thank all of the presenters today. What a fabulous group, and so interesting and articulate. Every single presentation had me learning something new. And thank you so much to Peggy March and Paul Van Zandt, who really they built this program. They got all of our speakers together. They did all of that construction to enable us to sit in our room today, our Zoom room, and have these great conversations. So thank you, heartfelt thank you for that. And thank you to GeoIgnite for letting us host this particular gathering in their vehicle. It's been a good conference. I've seen some presentations and questions that I hope those presenters came to this panel, because I think we've answered some of their questions. Right. So we'll wrap up for today. Thanks again so much for attending, for everybody.